A very good morning to Dr. Maslan, Dr. Julie, as well as the audiences. We are from Group 2 and today we would like to present you the nanotechnology in food packaging. Now I'd like to do the introductions of nanotechnology in food packaging. Nanotechnology is also shortened to nanotech. It is the use of matter on an atomic, molecular, and supramolecular scale for industrial purposes. Its nanometers within 1 to 100. Nanotechnology may revolutionize the food industry by providing stronger, higher barrier packaging materials, more potent antimicrobial agents, and a host of sensors which can detect trace contaminants, gases, or microbes in packaged foods. Multi-layered constructions are likewise extremely difficult to recycle. As a result, the packaging industry is under pressure to design packaging that promotes sustainable development, green consumptions, and the circular economy, which is based on the recyclability of packaging materials. Different nanoparticles oxides such as titanium dioxide TiO2, zinc oxide ZNO, silicon oxide SiO2, and magnesium oxide MgO do found applications in food packaging due to their ability to act as UV blockers and photocatalytic disinfection agents. This is according to Fujishima et al. 2000. Thank you.
So now I will talk about the proposed statement of our mini project. Based on our previous study, producing food packaging materials with desirable properties along with reducing their negative impact on environment and human health raise concerns among society due to the negative environment impact caused by traditional plastic food packaging. Biodegradable plastic packaging is suggested in previous research to solve this problem. Meanwhile, the improvement in technology makes the incorporation of nanomaterials as additive in biodegradable polymers a feasible option in enhancing their barrier and mechanical properties. However, there are still a critical problem which there has been inconsistent answer until now, which is regarding the potential of migration of nanoparticles from the food packaging material region towards the foodstuff in conjunction with its toxicological properties and harmful impacts on human health. Generally, our mini project proposed to provide some discussion and solution regarding this problem.
Thanks to my friend Sing Er, I will talk about my section. Objective. The first one, to study the effect of utilizing nanotechnology in food packaging to its mechanical properties and packaging quality. The second one, to determine the impact of incorporating nanoparticles as a food packaging material in a term of toxicity and ecotoxicity. The last, to investigate the suitable methodologies for the identification and characterization of nanomaterials. And then, I will pass to Shahril for the next session. Thank you.
Thank you, Azul. So, hi, Assalamualaikum. My name is Shahril bin Ahmad. My metric number is J19B0402. So, I will proceed to present about the content review. The first one is a previous researcher has focused on discussing nanomaterial potential benefits for food packaging nanomaterial. However, current knowledge regarding its migration from packaging into stuff and its toxicity to human health is still limited. The second point is the identification and characterization of nanomaterial, particularly when evaluating the migration potential of nanomaterial out of food packaging, means that nanomaterial will likely seep into food, which will cause adverse effect to health. For the third is, it was a difficult operation that necessitated the use of a specialized analytic technique, especially since it is nano-sized, which will influence the difficulty of operation. The fourth point is a focus on discussing the suitable method to improve the properties of the polymer nanocomposite in packaging and characterization technique for inspecting the nanomaterial. So we are looking for improving this nano packaging based on the various methods, so that it will give more safety. So that all from me. So I will pass to Ovia.
Thank you, Shah. Hi, my name is Ovia. Metric number is J19A0280. I will explain about methodology of this review. The first method is solvent casting. Polymer is dissolved in organic solvent at room temperature. Dope film is added with particles of a certain size. Dye slots are used to deposit thin liquid film on the glass plate. Then particle and polymers are mixed to produce a thin composite layer when the solvent is evaporated by the air dryer. Next method is thermocompression. Polymer thermally and preheated. Have high pressure, which is 10,000 psi, peeled film from aluminium. Next one is polymerization between collective inside. Clay material is physically mixed with monomers. Monomers are intercalculated in the interlayer. Swelling of clay material is necessary in this method. I will pass the next slide to Chauta. Thank you.
Okay, thanks Ovia. Now I'm going to present my part, which is method. Solution integration. Trace and solvents in different solvents. Two solutions are combined. This method has been used to create intermetal nanocomposite. Second one, character. The clay is mixed above the melting point of the polymer and stored under shell at the same temperature. Insoluble, intermittent and also fractal structure will result. A single polymer chain is injected into the clay layer gallery. The exfoliated nanocomposite silicate layer has been completely immersed. The third one, integrasi electro. SEM and also TEM are used to investigate the microstructure and surface morphology of polymer nanocomposite (TEM). EDX spectrometry is used to determine the chemical composition of films. XRD measurements are used to identify the crystallinity, crystal size, and structure of the composite. Polymer nanocomposite films were examined using various analytical methods, including AFM, TGA, and also NNR. So thank you, that's all from me.